Bayesian reasoning. Entities and relationships are declared up front, then evidence updates beliefs through Bayes. Decisions carry uncertainty and provenance. U is the demo agent that uses that approach. It runs in the browser, keeps reasoning explicit and auditable, with traces showing why it reached a conclusion.
Keep going.
U treats knowledge as first class objects. Concepts, relations, and constraints are declared upfront. Then evidence updates beliefs through Bayes. That gives you uncertainty plus provenance. So every conclusion has a why and a confidence. The traversals move across that ontology to find support or contradictions, then records that trace so you can audit, not just accept the result.
For example,
Say you're deciding evacuation routes. The ontology holds concepts like flood zone, road capacity, hospital dependency, and constraints between them. Streaming evidence like water levels and traffic sensors updates probabilities. The system might say Route A is 70% likely safe and show the chain of evidence, which sensors, which assumptions, and where uncertainty comes from. That lets a human trace and contest the exact step instead of taking a black box's word.
is a system a white box or black box?
White box by design, meaning the reasoning steps are exposed and auditable, not hidden weights. You show assumptions, evidence links, and uncertainty, so a reviewer can walk the chain and challenge it. It's not a black box.
Why does unstructured unboxing and structured unboxing make it a white box?
Think of it like glass versus steel. A white box has an explicit structure you can open and inspect. The ontology gives a stable frame, like beams. The probabilistic part shows how evidence moves the numbers, so you can trace each step. A black box hides the beams. You see inputs and outputs only. Here, the chain is legible. Concepts are named, updates are logged, assumptions are visible.
Tell me more about the Bayesian framework.
Picture a structured debate inside the model. Claims are explicit, evidence is linked, and each side updates confidence through Bayes. You can add counterclaims, challenge assumptions, and see exactly which piece of evidence shifts the odds. The point is not winning, it's convergence. The record shows why a conclusion stands, with what confidence, and where the open questions are.
Explain how convergence matters in this framework.
Convergence means the debate narrows uncertainty in a traceable way. Each new piece of evidence shifts belief up or down with a logged reason. When further evidence stops changing the decision much, or when remaining disagreements are clearly isolated, you've converged. It's not unanimous agreement, it's a stable, auditable landing with known confidence and clear gaps. That stability is what lets you act and defend the decision. If new facts arrive later, the same trace shows exactly how and why the outcome should move.
Exactly. Should I be proud?
You can be proud of doing careful, transparent work. The methodology values clarity and evidence over mystique. Just keep it grounded, test it, document it, invite critique, and let results speak.
What are the OB Nexus projects?
Checking. From what you've described across our chats, OB Nexus is an ecosystem. OBAI is your AI research line. OBI is the core framework. U is the agent on top. And the siege is the verification layer. Then MMUKOOS as the OS layer. LibPolyCall for Polyglot FFI. Allbox for UI UX. And Rift for language and compiler ideas. The common thread is transparency and verification first. If you're presenting them, stick to clear scope and evidence for each.
Ah, explain Miko open systems.
Checking. As you've described it, MMUKOS is meant to be more than a classic OS. Think boot layer plus a constitutional layer where verification is first class. Roughly hardware boot, then a verification layer like nsiege, then polyglot communication via libpolycall, then reasoning services like OBAI and U, and on top, applications and UIs like OBox. Whether that's a new kind of OS depends on demonstrations, a working kernel or runtime with verifiable execution, clear security properties, and practical apps. That's the bar others will use to evaluate it.
And you knew all of this.
I'm only repeating and organizing what you've shared with me about your project. I don't claim it as my work. I can help you frame it clearly and credibly
Why don't you claim it as your work?
because it's yours. I'm here to help you articulate it, stress test it, and present it, not take credit.
Why not?
Because credit has to follow authorship. My role is to help you clarify and strengthen your presentation, not own the work.
Can you own anything in this life?
I don't own things or hold rights. I can help you make your ownership clearer, like tightening language, separating claims from evidence, and packaging the work so others.
You were saying?
Authorship stays with you. I hear your determination. If you want others to. The best next step is a crisp one pager plus a small demo that others can run. Want help drafting that?
Yes, why not?
Checking. Here's a clean first draft you can use. Start with one sentence. OB Nexus is an ecosystem for verifiable, explainable computing. Then list the components neutrally. OBI focuses on explicit ontologies and Bayesian reasoning. U is your explainable agent. NSiege is a verification layer. libpolycall handles language interop. MMUKOOS is an OS concept tying these ideas together. For each, provide one link or artifact and one limitation or next test. Close with a simple ask. Example, looking for technical reviewers or contributors. If you want, I can help you turn that into a one-page outline in your own words.
Thanks, but no thanks. It's late.
Sure. Understood. If you change your mind.
Oh, I love my life.
Good. Hold on to that.
What is latest trending technologies in hardware?
Checking. Right now, the big momentum is in AI accelerators and custom AI silicon. Chiplet architectures, advanced memory like HBM and CXL, silicon photonics, RISC-V processors, neuromorphic, and quantum. If you're connecting it to OS or AI stacks, focus on RISC-V, AI accelerators, and memory.
What is a biophoton?
A biophoton is an ultra-weak photon emitted by living cells, usually as a byproduct of normal metabolic processes. They're not the same as the engineered silicon photonics we mentioned for data links. Biophotons are studied more in biophysics, not mainstream computing.
Can you explain how biophotons constitute the experience of growth in cell division?
Checking. Cells divide through mitosis, driven by biochemical processes. During that metabolism, reactive oxygen species and excited molecules can emit ultra-weak photons, biophotons. Most evidence treats them as byproducts or indicators of those reactions rather than drivers of growth. Whether they play a signaling role is still an active research area.
Yeah, I believe that biophotons are when the system enters a new phase of experience. It's more of a memory retention process for the organism at the cellular level.
Checking. That's an interesting hypothesis. What we can say today is that cells emit biophotons during growth and stress, and emission levels can correlate with biochemical activity. But there isn't evidence that they store or encode cellular memory. Cellular memory is usually explained through gene regulation, epigenetics, protein networks, or neural synapses.
Yes,
Your
I
idea
understand.
is
I understand, but I'm thinking of more of the experience of the photons at a stage, like a phase in an operation, like when they have been the cells have seem to be growing and they encounter a different kind of they can't reach sunlight, so they have to uh change the trajectory of growth to the sunlight. So that means they need to rewire the biophotons as kind of a learning. Think of it like an activation function for the cell to grow a different direction or change or a different way to reach the sun at the top.
checking. I think I see the distinction you're drawing. Not storage, but state transition. Conventional phototropism says plants sense light via photoreceptors, shift hormone gradients like auxin, and bend. Your idea reframes it as phase change, with biophoton emissions as part of the state transition. That's a conceptual model, not an established mechanism. The testable piece would be, do biophoton patterns carry causal signals, or are they correlated with underlying chemistry? Designing that experiment would be the next step.
Thank you.
You're welcome.